Today we are going to discuss coordinate graphs some more. This is Unit 9.2, Coordinate Graphs, Part 1. First, let's talk about plotting decimal numbers on a number line. Here you see a number line. I am going to plot the following points for you. Point A is 0.9. Since I know that 0.9 is almost 1, point A should go here. Point B is 1.5. Since I know that 0.5 is directly in the middle of any two whole numbers, point 1.5 should go here. Point C is 2.7. 2.7 is just a little bit bigger than 2.5, so point C should go approximately here. Point D is 3.8. Since I know that 3.8 is closer to 4 than it is to 3, 3.8 should be here. Point E is 4.1. 4.1 is just a little bit after the point for 4, so point 4.1 should be here. Finally, point F is 5.3. 5.3 is not quite as big as 5.5, so point 5.3 should go about here. Now, let's look at plotting points in the first quadrant of a coordinate graph. Here is a picture of a 4-quadrant coordinate graph. We are going to use only this part called the first quadrant. It is called the first quadrant because it deals only with positive numbers. To start this demonstration, we are going to plot the following ordered number pairs on the grid: 21, 14, 17, 11, 17, 13, 15, 14, 2, 16, 1, 11, 2, 8, 3, 6, 7.5, 5.5, 11, 2.5, and 12.5, 4. Here is the list of points in case you forgot. Just as we discussed in yesterday's video, you must first go either left or right along the horizontal axis and then vertically up or down along the vertical axis. Our first number is 21, 14. So we are going to go over to the right, since it's a positive number, to 21, and we're going to go straight up the graph until we hit the number 14. Our first point will be here. Our second point is 17, 11. We are going to go to the right 17 spaces and up 11, which puts our next point here. Here are all of the remaining dots graphed on our coordinate grid. Next, I am going to connect all of the points in the same order in which I plotted them. Here is what this will look like. Starting with 21, 14, I am going to connect that dot to 17, 11. Then I'm going to go from 17, 11 up to 17, 13. I'm going to continue this process until I've connected all of the dots in the order in which I plotted them. Next, I am going to connect 12.5, 4 to 17.5, 5. After that, I'm going to connect 21.5 to 21.5, 15.5 to 21, 14. Now that I'm finished, you can see the outline map of the continental United States. Within this map, you see that there are some points plotted that relate to different cities in our country. If I asked you to find the coordinates for Denver, Colorado, what would you write? Here's what your answer should be. The coordinates for Denver, Colorado are 7.5, 9.5. You can see that the X for Denver, Colorado does not land on any specific line, but instead sits right in the middle between 7 and 8 on the X-axis and between 9 and 10 on the Y-axis. If I asked you to plot the location of Salt Lake City, Utah, and told you that its coordinates are 5.5, 10.5, where would that point land? Your answer should look like this. As you can see, my dot is right in the middle between 5 and 6 on the x-axis and between 10 and 11 on the y-axis. This is 5.5, 10.5. Finally, we are going to explore plotting ordered number pairs and transforming pictures. A transformation is when we change a figure's size or shape. Take a look at this chart. Let's talk about the changes taking place in the numbers. In the first column, under the column labeled New Sailboat 1, you can see that the rule is to double each number of the original pair. If the original pair is 8, 1, a doubled pair looks like 16, 2, which is exactly what is written in the first column. The second row down, 5, 1 doubled looks like 10, 2. In the third column down, 5, 7 looks like 10, 14. What would 1, 2 look like if we doubled it? If you guessed 2, 4, you were right. Doubling 5, 1 looks like 10, 2. 0, 1 looks like 0, 2. Here are the remainder of these numbers doubled in the first column. In the column labeled New Sailboat 2, the rule is to double the first number of the original pair. That means that the second number should stay the same. For example, with the original sailboat numbers of 8, 1, we only doubled the first number, which gave us 16, 1, because the second number should have stayed the same. 5, 1, doubling the first number looks like 10, 1. As we continue on down the column, we are going to continue doubling only the first number. The remainder of the chart would look like this. As you can see, we only doubled the first number going all the way down the column. In the third and final column, New Sailboat 3, the rule is that we double the second number of the original pair. In this case, 8, 1 doubled with that rule looks like 8, 2. 5, 1 doubled with that rule looks like 5, 2. 5, 7 doubled with that rule looks like 5, 14. Here is the remainder of this chart doubled. Here is the completed chart. Now, let's plot all of these points on this coordinate graph. I am going to plot the points for the original sailboat only. Here are all of the points for the original sailboat plotted. Now, I am going to connect the dots in the order in which I plotted them. Some of the points are the same, so that means I will be connecting some dots to the same lines. Here is what my picture looks like now. As you can see, it is a sailboat. Next, I am going to use the larger coordinate graph to graph all of the points for New Sailboat 1. Here are what the points look like when they are plotted on the New Sailboat 1 coordinate graph. Finally, I am going to connect the dots in the same order that I plotted them in. Here is what it will look like when it's finished. Both sailboats are exactly the same, but the one on the right is bigger than the one on the left. New Sailboat 1 is twice as high and twice as wide as the original sailboat. The sailboat stretched in both directions. Here is your practice problem for the day. Plot the following points on the coordinate graph. Connect the points in the same order that you plotted them in. What shape does this make?